So guys, welcome to our channel once again. In today's video on our physics WAEC exam revision series, we have here these 10 WAEC repeated questions to answer on the topic fluid at rest. So this video will be about viscosity, volume, density and relative density. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, the property of a fluid that is used to determine its suitability as a lubricant is its A. Relative density, B. Capillarity, C. Surface tension, D. Viscosity. So guys, the answer to this question is option D, and that's viscosity. So viscosity is a measure of a fluid's resistance to flow, and that's it for this question. So let's go ahead and consider the next question, guys. So the next question we have here is question number 2. It says, a solid weighs 45 Newton and 15 Newtons respectively in air and water. Determine the relative density of the solid. So guys, we are going to use this formula. Relative density, that's RD, is equal to weight in air over upthrust. So guys, the weight in air here is 45 Newton, and then the upthrust will be the weight in air minus the weight in water. So that will be 45 minus 15. So that's 30, guys, and the relative density now is going to be 45 over 30, and guys, that's 1.5, and that's option B here, guys. Option B is the answer to this question. So let's go ahead and consider the next question, guys. So guys, we have question number 3 here. It says, a liquid of volume 2.00 meters cube and density 1.00 times 10 to the power of 3 kilogram per meter cube is mixed with 3.00 meter cube of another liquid of density 8.00 times 10 to the power of 3 kilogram per meter cube. Calculate the density of the mixture. Assume there is no chemical reaction. So guys, here we are going to use the formula that the density of this mixture is going to be M1 plus M2 over V1 plus V2. So remember that density is mass over volume, so that will be the mass 1 plus mass 2 over volume 1 plus volume 2. But then we cannot tell the mass from the question here, so we have to calculate for the mass 1 and then for the mass 2. So let's recall that mass is density times volume, right? So here density is rho, so we are going to have M is equal to rho V for 1, that's rho 1 V1, and then we are also going to have that M2 is equal to rho 2 V2. So in that case, M1 is equal to 2.00 times 1.00 times 10 to the power of 3. So guys, that's 2.00 times 10 to the power of 3. And then for the second one, we are going to have 3.00 times 8.00 times 10 to the power of 3. So 3 times 8 is 24. So we're going to have 24 times 10 to the power of 3 for mass 2. So for the volume 1 is 2, while volume 2 is 3. So guys, the overall equation here, you're going to have that rho is equal to so this is over 5. So guys, when we calculate this together, we're going to have 5.2 times 10 to the power of 3 kilogram per meter cube. So that's it for this question, guys. So let's go ahead and consider the next question, guys. So guys, that's question number 4 here. It says the maximum density of water occurs at the temperature of A 273 degrees Celsius, B 4 degrees Celsius, C 0 degrees Celsius, and D 37 degrees Celsius. So guys, the answer to this question is option B here, 4 degrees Celsius, and that's the anomalous expansion of water, and that's it for this question. So the answer to this question is 4 degrees Celsius. That's where the maximum density of water occurs. So let's go ahead and consider the next question. So guys, the next question here is question number 5. It says a quantity of water at 0 degrees Celsius is heated to 30 degrees Celsius. For each degree rise in temperature, its density will A. Rise steadily, B. Fall and then rises, C. Rise and then falls, D. Fall steadily. So guys, the answer to this question is option C, rise and then fall. So we can recall that the maximum density of water is at 4 degrees Celsius. So guys, when you heat water from 0 degrees Celsius, the density keeps rising as the temperature keeps increasing until it gets to 4 degrees Celsius, where you have the maximum density. Then afterwards, the density starts to fall as the temperature increases above the 4 degrees Celsius. So that's the anomalous behavior of water that we just talked about, and that's it for this question. Option C is the answer to this question. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 6 here. It says the relative density bottle of volume 50 cm cube is completely filled with a liquid at 30 degrees Celsius. It is then heated to 80 degrees Celsius such that 0.75 cm cube of the liquid is expelled. Calculate the apparent cube expansivity of the liquid. So guys, the apparent cubic expansivity of this liquid can be calculated easily using the apparent cubic expansivity gamma is going to be the volume of expelled liquid all over the volume of the remaining liquid times temperature rise. So here we're going to have volume of expelled liquid to be 0.75 cm cube, and then the volume of the remaining liquid will now be the total volume minus this 0.75. So that's 50 minus 0.75. So that will be 42.5. So this will be multiplied by the temperature rise. So the temperature actually increased from 30 degrees Celsius to 80 degrees Celsius. That's about 50 degrees Celsius temperature rise. So when we have this, we can now go ahead and solve the volume of expelled liquid, which is 0.75 over 42.5 times 50. So guys, when you calculate these together, you're going to have 0.00030 per Kelvin. So that's the cubic expansivity of this liquid, and that's option A here, guys. So let's go ahead and consider the next question. So guys, in the next question here, we have a couple of graphs here in the options, but let's read the question. It says, the graph of density against temperature for water is correctly illustrated by, so you see the graphs option A, B, C, and D. So guys, if you have this question, this is just a walkaway or walkover question. So all you just need to do is study the graph and then you get the answer correctly. So you see temperature rising from 0 degrees Celsius, and then you see when it gets to 4 degrees Celsius and keeps rising. So you also notice the graph plotted for density here, that the graph went up a curve and then after 4 degrees Celsius it started coming down. So this illustrates the anomalous behavior of water, where the density rises as the temperature is rising and then starts coming down as the temperature passes 4 degrees Celsius. So you see that in option A. So option A is obviously the answer to this question. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 8. It says, which of the following devices is used to determine the relative density of an acid? We have A, hydrometer, B, hygrometer, C, hypsometer, and D, manometer. So guys, the answer to this question is option A, hydrometer. So let's go ahead and consider the next question. So that's question number 9 here. It says an object weighs 60 newtons in air, 48.2 newton in a certain liquid X, and 44.9 newton in water. Calculate the relative density of X. So guys, an easy way we are going to calculate for this is finding the upthrust in X and that in water. So we are going to do the weight of the object in air minus the one in X over the weight of the object in air minus the one in water. So that would be 60 newtons minus 48.2 newtons over 60 newtons minus 44.9 newton. So guys, when we calculate this, we're going to have 0.782, and that's option A here. So let's go ahead and consider the next and last question for us here today. So that's question number 10 here. It says, a student measures the volume of a liquid using a measuring cylinder. What else needs to be measured by the student in order to determine the density of the liquid? So guys, this is actually one of the simplest questions you'll ever come across in your WAEC, because you know density is mass over volume. So obviously the next thing to measure is the mass of this liquid. Since you've measured the volume, you're going to measure the mass and then divide the mass by the volume. And that's it for this question. Option A is the answer to this question. So this is where we end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community where we'll post major updates on WAEC examination. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.